Hello friends, welcome to the Electronic Body channel. In this video lecture, we will study the basics of the timer IC555. The outline of this video lecture is: first we will see what is timer, then we will go for the what are the specification of the timer IC55, then internal architecture of the IC555, then functional block diagram of the IC555, then we go for the pinout diagram of the IC555, and finally we'll see the working of the timer IC555. Now let us say what is this timer. So this timer means it is basically what the monolithic circuit that produces the accurate and the highly stable time delays or the oscillation. So this is introduced in 1970 by Signetic Corporation and gives the name as ACNE 555 timer here. Then this timer IC555 is reliable and cheap in cost. It is also a combination of the digital as well as the analog circuit. Then it is known as the time machine as it performs a variety of the timing tasks. Then it works as a multivibrator. Basically it is work as a stable multivibrator or frenetic multivibrator and the monostable multivibrator. Now we'll go what are the important features of this IC555. So it basically operates on the +5 to +18 supply voltage. It will give the sink as well as source of the 200 milliampere load current. Then the external component, if you connect the external component by selecting the proper external component, so that we can vary the timing interval from microsecond to hours. The output of the timer can be driven as a TTL logic as well as the CMOS logic due to its high current output here. Then it has an adjustable duty cycle. You can vary the duty cycle here. Then it's provide the good temperature stability, better than 0.005 percentage per degree centigrade here. Output can be normally on or normally off. Power dissipation is about 600 milliwatt to 1100 milliwatts here. Operating temperature is from 0 degree to 50 degree here. Then we'll go for the internal structure of the timer IC555. We'll not go into detail here, but this is a diagram which will show the internal structure of the timer IC555. So it consists of basically the 23 transistors, then 2 diodes, 16 resistors like this here. Then the most important part of this IC555 is the functional block diagram of this 555 here. So you see this is the functional block diagram of the IC555. So it basically consists of what? 3 resistors. So these resistors, each resistor is of 5 kilo ohm. So these are the resistors which are shown here, 1, 2 and 3. They are connected in series here. Then it has 2 components, 2 comparators. You can say the C1 and C2, that is upper comparator and the lower comparator. There is one RS flip-flop and then one transistor which is called discharge transistor. There is output stage here. Finally we can get the output here. Then we will see the function of the each block here. Basically, as we know that it consists of the 3 resistors. Each resistor is of 5 kilo value here. So these 3 resistors, they will form the voltage divider arrangement here. The total voltage VCC and between the ground and VCC here, this voltage divided into the 3 parts here, 1/3 VCC voltage on each resistor. So therefore at this stage we can get the 1/3 VCC. Then at this stage we can get the 2/3 VCC, which is the threshold level of the upper comparator. This is the level of the lower comparator here. Then second block, we can say that the second is a comparator here. We know that this comparator having the 2 terminals here. One is a inverting terminal, other is a non-inverting terminal, and the output here. The output depends upon what? Whether the which input is higher here. If the inverting input is more than the non-inverting input, the output is high, or if it is less, then output will be low here. So in this case here, so it consists of the 2 comparator. This is the upper comparator, we can say C1. This is the lower comparator C2 here. So this upper comparator having the reference level of 2/3 VCC here, and the lower comparator has the 1/3 VCC here. You see basically here the reference level of this upper comparator is at the non-inverting, and for the lower comparator it is at the non-inverting for the lower comparator and inverting at the upper comparator here. So let us see how means here the reference level for this C2 means the lower comparator is 1/3 VCC and for the upper comparator is the 2/3 VCC basically. Then we can go for the next block here. So that is the next block is the RSP block here. It basically this is RSP block here, and this is the output Q and Q bar here. So it generates the two values, either the output is high or low. That depends upon the what is the input to the S and R flip-flop here. So we know the truth table of the RS flip-flop here. When both the input S and R, so they are the inputs here, which is the output of the comparator here. If both the inputs are low here, then it will not change the output. Means it is same as the previous one. There is no change in the output here. If the S is 1 and R is 0, then the flip-flop will get set here. If R is 1 and S is 0, the flip-flop will get reset here. And if both are 1, so this is we call a forbidden state, which will not be used in this case here. Then in the particular situation in the timer here, so here we'll find that here this is the reference level of the lower comparator is 1/3 VCC, and we provide the trigger to we compare this reference voltage with this trigger input here, which is given to the inverting input of this lower comparator here. If the input of this input trigger is more than the 1/3 VCC here, then what? And it is basically the negative. If you apply the negative voltage to this here, then this flip-flop will get set here. The output will becomes 1 here, so that we can get the output 1 here. The same is case for the upper comparator here. When this control voltage, or we can say the threshold voltage, if it is greater than the 2/3 VCC here, as the reference level is 2/3 VCC for this comparator, then the R will becomes 1, and when the R will becomes 1 here, then the flip-flop will get reset here, means the output Q will be 0. In this way, the output is either 0 or 1, means output is either high or low, depending upon what are the inputs to this here. Here means what are the input to the RNS flip-flop, means the output of the comparator, means what are the reference levels, what are the inputs provided to the threshold control as well as the trigger input here. So in short, we can say that when the threshold comparator saturate, the flip-flop is reset, means the output becomes low, means the pin number 3 will becomes low here. And when the trigger comparator saturates, means the output will becomes what? Flip-flop will get set and the output will becomes high here. So this is the situation for the RS flip-flop here. Then the next is we can go for the one more thing is here, there is a one discharge transistor is there here. So when the base of this transistor is low, since this transistor is NPN, when this transistor is low here, what will happen here? If this is low, then this capacitor which is externally connected to this pin here will get charged here. And if this pin is what? High, because this NPN, when this pin is higher, then the transistor will be working on state here, and the capacitor will be connected to this will get discharged through this pin here. What are the output stage here? It is just the inverter here, so therefore we can get the output Q here instead of Q bar here. Then this most important IC here, which is capable of producing the accurate and the delay time or the oscillations here. It is basically available in many packages, particularly in the DIP package as well as the TO5 package here. But mostly it is used the DIP package here. This is the DIP package of the IC555 here. It consists of the 8 pins here, 4 pin on this side and 4 pin on the other side here. Let us see the function of each pin now. The first pin of this IC we call it ground here. So all the voltages which are measured with respect to this terminal here is this pin. Now the pin number 2, which is we call it trigger here. So this trigger pin is what, depending upon the amplitude of the external trigger pulse which is applied to this pin here, the timer produces an output here depending upon the trigger which is applied here. So this pin is particularly used to provide the trigger to the circuit when the device will be configured as a monostable multivibrator. Then the pin number 3, which is the output pin here. So there are the two ways to connect the external load to this IC here. The first is either we can connect the load between the pin number 3 and pin number 3 and VCC. This is the one way here. And in another way, we can connect the external load between the pin number 3 and the ground here. So when it is connected between the pin number 3 and VCC here, it is called normally off here. And when it is connected between pin number 3 and the ground, it is called normally on here. So when suppose we say that the output is low, when the output is suppose low here, so what will happen? So in this case, the load current flows through the load connected with the pin number 3 and to the VCC here. So this is called a sink current here. This will flowing from this side to this side here. This is called a sink here. And when the load is connected between the pin number 3 and the ground here, so this is called a source current. The external current flows through this load from pin number 3 to the ground here. So in this way, this current is called as a source current, either sink current or source current. That depends upon whether the load is connected between the pin number 3 and VCC or the pin number 3 and the ground here. So this is the output pin here. Then the next pin is called a reset pin here. So you know that this reset pin is the connected to the, basically we see that this is the external connected to the RS flip-flop here. This will reset. It is the active low pin here. If this becomes 0 here, then the flip-flop will get reset here. Now if you see here, if you want to reset this IC here just by applying the negative pulse to this pin. But in most cases we are not using this pin here, and when the reset pin is not in use here, then it is connected to the plus VCC to avoid any possibility of the false triggering here. Then pin number 5, sorry, is called a control pin here. So here the external voltage is applied to this pin that changes the threshold level as well as the trigger voltage. In other words, by providing the voltage to this pin or connecting the potentiometer between this pin and the ground here, the width of the pulse of the output pulse is varied, and when it is not used, when this pin is not used here, then the control pin should be bypassed to the ground via 0.01 microfarad capacitor to provide any external noise disturbances here. Then the pin number 6, this is called a threshold pin here. So this is the non-inverting terminal of the upper comparator C1 here, which monitor the voltage across an external capacitor which is connected externally to this to get the particular timing waveform here. When the voltage at this pin is greater than or equal to 2/3 VCC, then the output of comparator C1 goes high, which will reset the timer here, which the output will become low here. Otherwise, it is high. When the this pin number 7 is called a discharge pin here. The external capacitor is connected to this pin here between this pin number 7 and the ground here. So this pin is internally to the collector of the transistor Q1 and is off. This is off and acts as an open circuit for the external capacitor connected between the pin number 7 and the ground when the output is high. On the other hand, when the output is low, then this transistor will get saturated and acts as short circuit, and it will short the external capacitor to the ground here. So in this way, by connecting the external component between these pins with resistors and capacitor here, we can control the timing of the this timer here. Then pin number 8, which is the VCC, here we can connect the plus 5 to plus 18 volt to this pin here with respect to the ground here. Means either we can apply the plus 5 volt to the maximum, plus 18 volt to this pin here. Now finally we can see as we see that the external functional block diagram of the timer IC555. So it consists of the, say that the 3 equal values of the 5 kilo ohm resistor. We divide the voltage input voltage VCC into the 3 equal parts, and it provides the 1/3 reference level to the lower comparator and 2/3 reference level to the upper comparator. So that is we call threshold comparator. So therefore the lower comparator will saturate when the voltage becomes negative voltage becomes less than the 1/3 VCC here, and the upper comparator will saturate when its voltage threshold voltage becomes greater than the 2/3 voltage here. So in this way the output is high or low. That depends upon what are the external